Yep, so we did those. We were in the process of domain and range. We had just finished this basically double reflected radical square root equation. And then this next one is not number 10, it's number 12. Y equals 1 plus 1 over x squared. So, I don't know about you, but I truthfully, off the top of my head, really don't know what this looks like. I would have to sit and plot some points on it. The only thing that I really know is that with this x squared being on the bottom, well, it's going to be like a fraction. I'm guessing it's been shifted just because of that, but I know that there's going to be an asymptote at x equals 0. Because of the denominator. So if I set up a little graph over here and we'll just kind of see.
Oh, that's the bigger on bottom.
No, this is vertical asymptotes when the denominator is equal to 0. And then horizontal asymptote would be, we look at Bobo, Botno, Bosco. So this one's bigger on bottom, so there's also an asymptote at y equals 0. So I'm just going to note here, vertical asymptote at x equals 0, horizontal asymptote at y equals 0. It doesn't ask us for that, but I just think that's a good refresher to have. So I am basically going to just essentially throw some points in here. I'm going to go with like 1. So when it's 1, or when x is 1, y is 2. So I'm just going to get a rough. When x is 2, y is 1 1/4. When x is 3, y is 1 1/9. So basically getting an idea that it looks something like that on this side. Which kind of makes sense for like what I would think that it looks like. But I need to also check the negative x value since there's an asymptote, because we can have things on multiple sides. So do the same thing, but like with -1, well, that would just become a +1, so that would be 2. So at -1, it's up here at 2. Then at -2, it would be at, again, 1 1/4. So basically, we just have the same deal. It's just reflected across here, which would make sense. And so, same thing here. Rough sketch of what that looks like. So then the domain would be what?
It doesn't touch the x-axis. Unreal,
Yeah, so it's basically all real numbers except for x equals 0, or we could say -∞ to 0, not including, because of that asymptote, union 0 to infinity. Sometimes you'll see it written like this, all real numbers minus the set containing 0. It's a little bit less common to see this notation, I would say. I would say the way that I've read it initially is probably the most common way you'll see it. And then your range is now, I didn't really do enough for us to actually look at the range, so let me backtrack and talk about that for a second now that I'm looking at it. So if you remember, I said we're shifted 1 in some direction. Well, because it's not touching the x, that means it's an up and down shift. So when I was at, say when x was 3, I was at 1 1/9. If I go to 4, I'm at 1 1/16. If I go to 5, I'm at 1 1/25. So it doesn't touch 1.
Yeah.
Technically, the asymptote is more so if the whole thing is there. So realistically, but because it's been shifted, really my asymptote's also been shifted. And so my range would technically speaking be from 1.
Oh, yeah, 1 to infinity.
Yep, 1 to infinity and not including, because it's going to get really close to 1 but never touch 1. We didn't really look at horizontal asymptotes in that sense, so really to do that we would need to get a common denominator and combine them. before we could technically do that. So, but anyways, it wasn't asking us for that. It was just kind of like looking at that and then obviously it being shifted. All right, the next thing is, well, there are a few problems that say to like use a grapher and identify the domain and range, meaning they give you something like y is equal to 2 times the square root of 3 minus x. I trust that you could plot that and then just analyze what's happening to it if you needed to. So we're not really going to do that, but at this point, I assume you know how to use your calculator overall. So I'm going to do stuff by hand unless it's something that I know for a fact would be a calculator style question when we get toward like more of the exam type material. This is just review stuff, so I'm not really going to worry about it right now. So the next ones say to determine whether the function is even, odd, or neither. Try to answer without writing anything except the answer. I think that there's a lot of good in that, but I also think that it's good to look at the why behind it because I think our pre-cal book is actually very confusing in determining even, odd, and neither. But if you remember, that's where we check by plugging in negative x to the equation, and based on if it comes out where it all stays the same, if it all swaps signs, or if it's a mixture of signs is how we determine what it is. So we've got y equals x plus x squared. So we have, just gonna see, just as a review, if it's even, when we have f of negative x, it's gonna be equal to f of x. So basically, that's just kind of the way I think about it is like, okay, if I have x squared, I put in a negative, it comes out positive. Because x squared, I know for a fact that that's even. And then for odd, I have f of negative x. Well, that's going to come out to be negative f of x. Because if I have, let me say x cubed, I know that's odd. Well, if I plug in negative x to an x cubed, the whole function comes out negative. Now, obviously, that's more like if we have a bigger function that we're thinking about that. And then if it's neither, it's a mixture of the two where like maybe one sign changes instead of like all of them or something like that. So with this problem then, I'm going to say f of negative x. So I'm going to put a negative x here everywhere. So I've got negative x plus negative x squared. And so what I want to see is not that it has to come out positive or that it has to come out negative, but that it comes out with either the same sign I started with or the opposite sign of what I started with for it to be either even or odd. So in this case, this was obviously just an x. Now it's negative x. And then over here, negative x squared is positive x squared. So now one is negative, one is positive. So that means that this is neither. I think as far as when I teach even, odd, or neither, I think that my least favorite book to do it from is the pre-cal book. It is the most confusing of all of them.
I got so lost last year.
Everybody always does, and it's like, I'm like sitting there and I'm like, well, I have to teach it, but it's like, which it's not even really tested on the AP exam, so it doesn't really matter that much. But
They were easy, but I just got lost and I never spoke up last.
when they're a fraction, people get confused.
Yeah.
Because the whole fraction has to change or the whole fraction has to stay the same. But people are like, well, the top was the same and the bottom was, I'm like, okay, well, then it's neither. Like, it's just, I don't know. There's a couple in the pre-cal one that I have to, like, sit there and really think about because they're crazy. 26, y equals x plus x cubed. So I'm going to do the same thing. Now, this one, I would hope you can look at and say,
Hey, this one's odd.
this one's clearly odd. That's what the book is wanting you to be able to do. I'm just writing it out so that we can see why. So we would have negative x plus negative x cubed. Well, that becomes negative x minus x cubed. So the way that we get to this, the whole function is negative, is I could take a negative out. So it's negative parentheses x plus x cubed. It's a whole negative of the entire thing that I started with. But again, these technically tell you that they just want you to look at it and decide. The previous one, hopefully it was pretty obvious that one of the things was going to be odd, one was going to be even, and so it can't be, the function as a whole had to be a split. Now on one like 30, these are the ones that I think can look a little bit more confusing. But we've got y equals 1 over x squared minus 1. At first glance, what do you think this is going to be?
It looks even.
Yeah. So if I plug in negative x, I get 1 over negative x squared minus 1. Well, that's just going to become 1 over x squared minus 1. It's the exact same thing I started with, and so that means that this is even. Seemingly forgot to write odd up there.
Any, like,
What?
ones that you could show us? Things that you were talking about, like, that were struggling you a little bit? Well, not like struggling,
This book just doesn't really have any that are confusing. It's just the pre-cal book, the ones we did them last year. It's technically one I was going to give you, but we'll go over this one just to make sure, because this is probably the most confusing one in here from my quick glance at it. Y equals x cubed over x squared minus 1. I just think that our book last year was more confusing because it wasn't just like one variable on top. It was like a string of things, and it just gets confusing. At first glance, what do you think this is going to be?
I mean, neither. Because it's gonna have a positive at the bottom and a negative on top.
Negative. Yeah, I see what you mean. Wait.
So, maybe not. So let's look at it.
Oh, wouldn't that mean the whole problem is negative?
So if I plug in negative x, then what's going to happen is I'm going to get negative x cubed over negative x squared minus 1. So the top is going to be negative x cubed. The bottom is x squared minus 1. Okay, so the bottom, what I see is it's exactly the same. The top is different. But with a fraction, since it's the top that's like this, I can take and put that negative out front and have x cubed over x squared minus 1. This whole thing has become negative, so that means it's odd.
Whoa.
So that's why I was like, it's a little bit more complicated than the others for that reason. Okay, if I swapped it, let's say instead the problem was x squared over x cubed minus 1. Let's see what would happen with that one. So I would have f of negative x is going to be negative x squared over negative x cubed minus 1. Well, the top of this is now positive. Over the bottom, I have the first term is negative. So it's going to be negative x cubed minus 1. Well, the only thing here that changed was this sign. So this is going to be neither. So it's the same things, the same numbers obviously, or the same variables that we had in the previous one. The difference is because the negative was on top on a single term, it can go to the whole thing. All right, so the problems with this section are going to be 1 through 29, every other odd. So that should hit kind of a variety there for you. I'm pretty sure if it was to end on 27, because I didn't calculate out which ones it is, do 29 instead since we just did 27.